Today we're going to do functions, all right? And more specifically, we're going to talk about what is and what is not a function. We're going to tell you that one of these is a function and one of these is not. Okay? All right. So, functions. We can say that a function is sort of like this magical box, all right? We put something in this case right here, we're putting in a 4. And every time we put a 4 in this box, we're not sure what happens in it, but out kicks the other end an 8. Okay? We're not sure what happens. We have a pretty good guess. All right, what do you think could be happening inside the box?
Times 2.
Could be times 2. Does anyone think of anything else that could be happening in the box?
Adding 4.
Adding 4. So we don't really know, right? But what's important is every time a 4 goes in, an 8 comes out. Okay? Over here, this is another example of a function. Over here, a 4 goes in, a 5 comes out. A 4 goes in, and a 5 comes out. 4 goes in, 5 goes out. What could be happening in this function?
Plus 2 minus 1.
Could be. Anything else?
Plus 1.
Plus 1. Okay. Very possible. Both of these are functions. And these are functions because every time I put a 4 into this function, what am I expecting to come out?
An 8.
Alright, and from this function box, if I put a 4 in, I expect a
5.
okay? So they're predictable. Alright? Functions are predictable. Alright? So these would be not functions. This one right here, I drop a 2 in, a 3 comes out the first time. I drop another 2 in, a 4 comes out, and then a 2 in, and a 12 comes out. So next time I put a 2 in,
It could be a whole different.
it could be a different set of numbers that's in here. It's completely unpredictable. We don't know what's happening. So on the other one, we at least had some guesses about what's happening. Is there any way you could guess about what's going on in this function? Probably not, right? Alright. Would you say that this is unpredictable?
Yes.
Okay. Here's another example of a non-function. I put a 5 in, a 6 comes out. I put a 5 in, a 12 comes out. Put a 5 in, a 17 comes out. Again, it's unpredictable. We don't know what's going on inside of there. And in this case, it's not even repeatable. Alright?
Yeah.
Nick, any questions?
It don't look the same when the bottom comes out.
They're not the same whenever it comes out. Yes.
Could it be a different, a different formula for each number?
For a function, it has to be one formula for this whole box. Okay? Alright? So, here's another situation. Which one of these is a function?
The one on the left.
Why?
Yeah, but it's great.
Because it's gray for one reason. What about the numbers that makes it a function?
The bottom, the
1, 2, like it multiplies by 2. Like
What are you saying, Nick?
I think 2 twos, 1 4, but there's different numbers.
So where did these two twos come from,
it
Nick?
double.
Multiplication and
Well, every time I put a 1 in,
they got it from there.
I caught a 2, right? And a 2 and a 4, I don't have anything to compare it with.
Well, on the right, the 2 does not bring down the 6.
Well, the 2 brought down a 6, I'm okay with that. But I put a 1 in and it gave me a 3. And then I put another 1 in and it gave me
4.
a 4. So whatever's happening is not consistent, it's not predictable. If it was a function and I put a 1 in and got a 3 out, I would expect every time to put a 1 in to get a, which would be a 3 in this case. Clear as mud now? Okay. Alright. So a function is what? What could you say, Nick?
It can be the same.
It can be the same. Okay. Can we use another word for that?
One thing that happens to one number has to happen to the other one, and it's predictable.
Okay, I like that. Predictable. Alright, so we need to say that a function is predictable. Predictable. So we could say a non-function, or something that's not a function, is what, Dave?
Unpredictable.
Unpredictable, okay? Unpredictable. We're gonna define these a little bit more, but as a general rule, a function is predictable and a non-function is unpredictable. Okay? We good?
Yes, sir.
Alright, so here it's given to us a little bit differently. We're given a set of inputs, or x values, and a set of outputs, or y values. So looking at this input and this output, would you say that this is a function, Corey? Why not?
Because you're gonna sum the 0 and the 5.
So you think the 0 and the, you think this is what's making it not a function? Why?
Like, it's not the same, it's not doing, if you do the same thing as all the other ones, it's not working that way.
It's zero.
Yeah. Zero.
Okay, does anybody have any other opinion? Amelia?
The 1 and an 8 and the 1 and a 7.
Alright, so Amelia is focusing on this. Why do you say this, Amelia?
Because they're not, the Y is not the same, but the X is
So I'm putting a 1 in one time, and I get out
8,
an 8. I put a 1 in again, I should expect to get,
another 8.
but I got a 7 instead. So this one input yielded 2 different outputs, right? So, is this a function?
No.
So this is not a function, right? Alright? What about this one over here?
Yes.
Why?
Because the 1 and the 1 and the 8 and the 8 are both on the same side.
So, Tanner, could you restate what he's trying to say?
He's saying, because the 1 and the 8's the same on both, that is a function of it.
So they're the same.
If you put a 1 in, you get another 8 out.
Okay. So if I put a 1 in, I expect an 8 out. I tested it, I put another 1 in, I got an 8 out. So this one would indeed be a function. Okay? So in terms of this, if I have one input to be a function, I can only have one output. Over here I had one input, but it gives me 2 outputs, or more than one, okay? So let's define them a little clearer. A function is what?
Predictable.
It's predictable. So let's talk about in terms of inputs and outputs. What would you say?
When you would put one of the same like number, you expect the same output.
Okay. What are you gonna say? For every what? For every function? So for one output for every input? Is that what you're saying? I would say that. And what are we using as outputs and inputs in this case? That we're just looking at? What values?
1
0,
X,
6,
Y.
6, and 9.
Okay. So what was our input?
X,
It was our x's, and our output was our
Y.
y. So more along these lines, what would you say is a non-function?
More than one input.
More than one or twice.
More than one what, Nick?
Number.
Number, what about one of these words? More than one what?
Input or output. Function.
What do you think? Which one, let's go back and look at it. Which one can I not have multiples of?
You can't have the 7 together.
Right here? So I have 2 different,
Numbers.
and what are the y's? The y's are,
Different.
help them out.
Output.
Outputs. So I can have, not a function is more than one output for every input, okay? More than one output, or what value are we giving to output? Y. For every input that we're given the value of
X.
x. Is that what you're trying to say, Nick?
Yes.
Okay. Joe, you with us? Alright. Okay. So, Pam, come up here. Find one that is, so just go mark this one. Tell me, is it or is it not a function? If it is a function, check it. If it's not, cross it out. Why? So based on our definition, how would you say that it is a function?
That has only one input.
It's predictable.
Let's see one,
It's predictable.
let's see one of them.
Okay, well come find me one, Nate. Good job.
The one, two ones.
Why do you say that that is a function?
That's not one, supposed to be a two.
Well, I put a 2 in the machine, it kicks out a 1. I put a 1 in the machine, it kicks out a 1. I put a 2 in the machine, it kicks out a 1. So is this predictable? What does this machine do?
Make one.
It makes 1,
A whole lot.
right? So every time I put a 2 in, it's still giving me only 1 output, right? So this is still a function. I was trying to trick y'all with this one. You did a good job. Alright, Jesus, you wanna come do the next one? So is it a function or is it not a function? Why?
Because putting a 2, it came out a 4. Which would have been putting a 2, it came out a 4. And since there's only one, you can't compare it.
Nothing to compare it to. Very good. Emilio. Why not?
Because you have 2 to come to 7 and then 2 to come to
So in this case, you have what?
add more than
More than
Not
one.
predictable.
It's not predictable. You have more than one what? Output for every input. So X that sucker out. Awesome. Corey, try your hand. Why do you say that? Y'all agree?
Yes.
Alright. So, looking at it really, what, in each of these cases, I know there's only 3 values you're looking at, but what are the only ones that matter?
The 2 that
Right, so in this case, I'm only gonna look at the 7s. So for it to be a function, I should expect what? The same thing to come out of it. Is this the same? So this is not a function. Here, I have 7 doubled up. I expect the same thing, right? So is this a function?
Yes.
I put a 7 in, I get a 9. I put a 7 in, I get a 9. Is it predictable?
Yes.
This is a function. Here, the 4 doesn't matter because Jesus said earlier we don't have anything to compare it to, right? So I look at the 7s. Put a 7 in, I get a 1. 7 in, I get a 1. So is this a function?
Yes.
This is a function. Okay. Alright, so do we feel like we sort of understand what a function is and what it is not based on a table?
Yes.
Alright, so now we're gonna complete some practice on our own. I'm gonna come around and talk to you while you're doing it. So I'm gonna pass these out and then we'll get busy. Alright?